In this case, we're finding the Laplace of a derivative. And to find the Laplace of the derivative, we'll apply the formula. We have the integral 0 to infinity e to the negative st times the derivative, integrate with respect to t. And here we want to apply integration by parts. If I let u equal e to the negative st, then du is, I'll have to bring down the negative s, e to the negative st dt, and dv will be f prime t dt. So when I integrate, that'll get me back to my original function, f of t. So here, integrating by parts, I get u times v, that's e to the negative st, times f of t. And putting my limits on, I have limits at 0 and as t goes to infinity. And then minus v du. Limits go from 0 to infinity, and v du gives me e to the negative, no, it gives me ft times negative s, I'm going to bring that negative out front so it becomes a plus, s e to the negative st dt. Now on this first term, when I apply the limit, again the limit as t goes to infinity, as long as s is greater than 0, e to the negative st will go to 0, and so that'll give me a 0. And then at 0, I'm going to get e to the 0 power times f of 0, which will give me negative, this will become a 1, e to the 0 power is 1, gives me negative f of 0, which is actually one of the initial values. If you're given a 0 to substitute in for t, that gives you f of 0. Anyway, if I look at the second term, I can bring out the s, and if I rewrite this so that my e to the negative st comes first, then notice that this second integral here is my definition for Laplace. It's the Laplace of f of t. We're going to make a definition, and we're going to let the Laplace of f of t if you notice that when you take the Laplace of f of t, then I'm going to go back through our other examples. Notice that our answer is always a function of s. Notice all of our answers, the variable s is used to define it. 1 over s minus 4, 3 over s squared, 1 over s, 2 over s to the third, e to the negative s times 1 over s plus 2 over s to the third. When you take the Laplace of a function, you end up with a function of s. So I'm going to call this f, capital F, of s. And so I can rewrite this Laplace of f of t as capital F of s. And this usually shows up as s f of s minus f of 0 is the Laplace of f prime of t.